here for graphing sine or cosine, and if you see the video name, they're called sinusoids. A sinusoid is a sine or cosine function, something that has that sine shape. So we're going to be graphing these when the amplitude changes, which is like the height of the curve. So two methods I'm going to go through. Number one would be using our points from the parent function. And then similar to what we did in the beginning of the year, changing them with the transformations. So this 3 outside of the parent function, if it's not in the parentheses with the x, that means it changes the y. That's some stuff we did from early on this year. So that 3 is going to be a vertical stretch. It's going to multiply all of the y values by 3. So if you check our first page, when we graphed our sine function, we had all of these points: 0 degrees, 0, 90, 1, 180, 0, 270, -1, 360, 0. And you kind of have two options. You can either memorize the points or memorize what the graph looks like, which we'll go over. So I would take all these points and I'm going to multiply our y's by 3. So our new points, all of our y values are going to change. So 1 will change, 0 didn't change, right? All the zeros are going to stay the same. These are all degrees. And our 1s will essentially turn into 3s. So now I'm going to graph this on my graph. I'm going to mark my x-axis first, call all these, like every 2 lines, I'll do my markers. And put my points in. So now we have 0, 0, 90, all the way up at 3, 180, 0, so back to the midline, 270 at the bottom, and 360 back to the midline. So the other way to graph would just be, remember that's the shape. We're going to the top, to the midline, to the bottom, to the midline. So if I kept this pattern going, next I would go over 2 more, up to the top. Over 2 more, back to the midline. Over 2 more, down to the bottom, and just keep that pattern going. So if we were to go to the other direction, if we wanted to go this way, I'd go over 2, down to the bottom. Over 2, back to the midline. So I'll ask you guys to graph at least 5 of these key points on each graph. So the other way we could do this would actually just be to jump right to the graph and not list all these points. So for example, our next one, 1/2 cosine x, we should still think about this. 1/2 is going to be a vertical shrink. 1/2 times all the y values. And that just makes our amplitude equal to 1/2. So I'm going to graph the original cosine curve first. I always like to write in these markers, or at least know I'm going like 4 lines, whatever you decide your units to be. And I'm going to graph in black. I'm going to just graph cosine x. So cosine starts at the top at 1. And you see I'm spacing out my y-axis here because our amplitude is at -1. So for our original cosine curve, I'll be at the top at 1. Then I'm going to the midline. So cosine is essentially just pushing your sine over. So you got the mountain starting. So after I'm at the midline, I'm going down to the bottom, back to the midline, finish at the top. So I'll do this as a dotted line. That would be our parent function. This is just plain old cosine. So now I'm going to graph 1/2 cosine. That means instead of starting at 1, I'm starting at half of the height. But 0, those points are going to be the same. So any mountain or valley, we're half of the height that it used to be. So I'm just going to fill right in these points, and that would be it. So to keep going and keep my pattern going, if I'm at the top, I need to go back to the middle. If I'm at the middle, got to go to the top or bottom. So keeping this pattern going throughout my graph. All right, so you guys try out the next two. Check your answers on Desmos or with your calculator if you want, and I'll check them for you also, and let us know any questions.